Hi everyone, welcome to the second week of the webinar series brought to you by Charles Sturt University in collaboration with Bill Jerome. This week we're going to cover or build on the stuff that we covered last week, which was really the overview session of where Windows Phone is and where its sort of journey to where it's come to. This week we're going to continue on that discussion and look at the life cycle of Windows Phone applications. We'll look at background agents, tiles, and notifications. We do have quite a bit to go through, so there'll be quite a lot of slideware with a few demos interspersed. Feel free to ask questions during the webinar. I can't promise to get to them all until the end. I will try to factor some time at the end of the call to make sure that we get an opportunity to answer those questions. And actually, during the week, if you haven't already, you should check out the forums for this course. And there'll be a slide at the end just covering how to get access to those. And so that's a good place to ask questions. It's also where the labs for the week are posted, as well as we're posting the recordings and the slides for the week. Now for the second week, the slides have actually been already posted to the site along with the labs for this week. So those will be available right away. The actual recording for the session will probably go up either later tonight or tomorrow some stage. All right, without further ado, let's kick off. So we do have quite a bit to go through. And today's session is really looking at the life cycle of a Windows Phone application. And I guess the main points that you need to know in terms of building your application as the user moves in and out of your application, what you need to do in terms of saving data, in terms of restoring data, those types of things. So we'll look at the overall life cycle. We'll look at how Windows Phone detects whether it's in focus or not. We'll look at a new concept called Fast Application Resume. And just a recap of the basic page navigation and the backstack model that's there in Windows Phone. And we'll finish off with a discussion around background agents. So that's essentially what your application can do in the background whilst it's not being used by the user. We'll look at tiles, lock screen, and push notifications. And there's a bunch of new tile templates that you can now take advantage of in Windows Phone 8. And you can also integrate your application into the lock screen. So we'll look at how you do all of those. So kicking straight off, the Windows Phone application lifecycle really deals with how our application behaves as it goes from not running, so when the user's first installed it, through the launching phase to actually executing, what happens when the user closes your application, and what happens when your user goes in between your application and other applications on the platform. So for example, your application might be running, the user hits the start button and launches another application. What happens within your application and how you deal with it. And then we'll look at what the process is when the user then comes back to your application and you have to deal with the return data. Okay. The other thing that's added, as I mentioned in Windows Phone 8, is that we've now got this ability to fast application resume. And essentially this is about relaunching the suspended instance of your application. So for those who haven't worked with Windows Phone in the past, one of the big differences between Windows Phone and some of the other platforms is when you go to the start screen or you go to the application list and click on your application, that's going to launch your application. Irrespective of the application has been launched previously or it's currently running, going to the start screen and going to the application list will actually relaunch your application. Now, on other platforms, it's not the case. If you've already got an application running, you go to the sort of the main home screen, and if you click on their icon again, it'll actually go back to that existing application already in memory. So one of the changes introduced in Windows Phone 8, and this was done for a couple of scenarios that we'll talk about soon, is this ability to do fast application resume, which will actually relaunch or it will return to the already running instance in memory. So rather than having to relaunch the application, it'll actually resume the suspended instance and bring it into the foreground. And there's a couple of little things that you need to be aware of if you're going to take advantage of this capability. So what happens when the application is launched? Okay, at an application level, there's a couple of events that get raised. One when the application is launched, so that's the launching event, and the other one when the application is closing, so this is the closing event. Now, one thing to be aware of with a Windows Phone application is there's realistically only one way the application can be closed, and other than it crashing or throwing an exception, which are obviously not desirable. from the running state, if the user continues to press the back button, eventually they'll get back to the first page of your application, and then if they hit the back button again, that'll actually close your application. So this is when the closing event will happen on the application. Now if the user decides to launch another application, so they hit the start button and go off to another application, that's not closing your application, that's just suspending it and putting it into the background. And even if they actually go back to the start screen at some other point and then click on your application will be relaunched, but the previous instance of your application will never actually be closed. It'll just be terminated from memory and you won't get that closing event. Okay, so you just need to be a little bit aware that sometimes that closing event doesn't always occur. So there's no guarantee that you'll get a launching and then a closing as a pair. When our application goes into the background, and by this I mean the user's pressed the start button or a toast notification for another application has come in, so for example an SMS and they've clicked on it, the user will navigate away from your application to another application. This will move your application from the running state into what we know as a dormant state or a suspended state. In this process, there's a deactivating event that again gets called or raised at the application level. And that's your opportunity to clean up or to basically persist any data that you want to survive going into your application going into the background. Now, one thing to be aware of with your application going into the dormant state is that there's also this state called tombstoned. And essentially what happens is if your application is suspended, goes into the background, into this dormant state, your application is still resident in memory, even though it's not actually getting any cycles to execute on the CPU. If, however, the device runs low on memory, so for example, the user's opened up Internet Explorer, opened up 3 or 4 different tabs, all of a sudden the system says, oh, I'm running short of memory, it can go back and reclaim that memory from those applications that are in this dormant state. And what happens is that the system comes along and basically rips those applications out of memory, and they move into this tombstone state. Now the user can still go back between applications and eventually get back to that application. The difference here is that instead of it just coming back in, the application coming back into the foreground, that application's actually going to be restarted and relaunched back to where the user had left it. Okay, so it's a significant difference. One, you've got the dormant state where the application's in memory and it just comes back into the foreground. The other is this tombstone state where the application is no longer in memory and it's going to be relaunched and then brought back into the foreground. Now, both from the dormant state and the tombstone state, but in both cases you'll get this activating event happening at the application level. And we'll talk a little bit in a minute about how you can handle this on a page-by-page basis. So the one note to make here is that there's no guarantee that your application will ever be resumed if it goes into this dormant state. So your application may be dormant, it may go to tombstoned. From either of those states, the user may decide to go back to the start screen and relaunch your application. So again, there's no guarantee that you'll get this deactivating and activating occurring as a pair. One of the things that we'll talk about just briefly here is this concept of fast application switching. Now this is not to be confused with fast application resuming. Fast application switching is the ability for the user to switch between any one of the open applications by pressing and holding on the back button, swiping, as you can see in the image, to another one of the running applications. Okay. Now essentially what's happening here is rather than deleting everything in the backstack until it gets to the application the user wants to switch to, the application they switch to actually gets pulled out of the backstack and moved to the front of the queue, essentially. So this is just essentially a quick way for the user to navigate through the running applications. So I mentioned before that we do need to handle this dormant state, and essentially this happens because once the application goes into this dormant state, there's no guarantee that it's going to come back into the foreground. Okay. One of the nice things about it going to this dormant state, though, is that when it does come back into the foreground, because it's always been memory resident, there's very little to do within your application. Okay. However, when you move on to dealing with the tombstone state, you actually need to recover any of the saved state or the memory or the input from the user that was previously on the screen. So for example, the user might be halfway through filling in a form, your application might go into the background because they've launched another one or they've clicked on an incoming SMS. All of a sudden, the system decides that it's going to move your application from this dormant state to the tombstone state, and now when your application comes back into the foreground, the application comes back into the foreground, but none of the form fields that the user was expecting to be populated have actually got any data in there, because essentially because your application's come back into memory and it's been relaunched, you've lost all of that information. So as part of this, the deactivating event, so when your application goes into the background, you actually need to save any of the transient state for the user. Now clearly there's some state that you will always want to persist for the user. So for example, if the user had created a document within your application, that information, when they hit the save button, you'll want to save that off to isolated storage, okay? Irrespective of whether the application gets suspended or whether the application gets closed, when the user comes back to your application, they'll want to see that data there. However, in the case of the user filling in some form fields, if the user goes back to the start screen and relaunches your application, they're not expecting that data to be there. However, if they go off to another application because they might be interrupted, and then they come back to your application at a later stage, they'll remember that they were halfway through filling that form in, and they'll want to see that data there. So that's what we refer to as transient state. And it's really important that it's when you're building your application to think about what transient data you have on the page, and make sure that when your application goes into the background as part of the deactivating event, or on the page-by-page basis that we'll talk about in a second, you actually save that data to a state dictionary. So the question comes up, okay, well, how do we detect if our application has been gone into the dormant or tombstone state? Well, one method is actually in the application activated event. You can actually see that there's an attribute on the event tasks that is application instance preserved. Now, I don't know why they didn't call it is dormant or is tombstone. That would seem a much easier thing to work with, but we can't change what they called it. So basically, is application instance preserved essentially means that the application stayed in memory. Okay, so it went into this dormant state, and essentially this means that you probably need to do very little when your application comes back into the foreground. However, if your application is tombstoned, so the application instance wasn't preserved, you'll actually probably need to reload or rehydrate some data values. Now, there's a bit of a trick with Visual Studio to actually debug this whole tombstoning process. One of the challenges we have with particularly the Windows Phone 8 devices is it's actually very hard to encourage your app encourage the system to tombstone your application. In fact, in most working situations, you'll probably find that your application is not tombstoned. Okay. In the case of debugging this stuff, essentially there's a checkbox available in the project properties dialog that says tombstone upon deactivation while debugging. Now this doesn't affect the runtime behavior of your application. What it means is that when you're debugging the application, if you were to navigate away from your application, so you hit the start button and go off to another application, the debugger will stay attached, your application will be tombstoned, so you'll get the deactivated event, your application will be tombstoned. When you go back to your application, so you either use fast application switching to press and hold on the back button and navigate to your application, or you just press the back button to come back to your application. Your application will be reloaded into memory, and you'll get that activated event, so you can effectively debug and step through the code. Now, I've talked about persisting the transient state, so the question is, how do we do that? Okay, and I kind of touched on this concept of state dictionaries, and this state information can basically be saved in these state dictionaries, and they exist at two levels. There's an application-wide state dictionary. Okay, so we can see here that the phone application service.current.state is a key value dictionary where we can basically put in any serializable object. Okay, you can do this at the application level. In fact, you don't need to wait for the deactivated or any of the other events. You can actually save content into the state dictionary at any point within your application. Clearly, when you come back into your application, you can then reload from that state dictionary in the activated event. Now, The other thing that you may find easier is actually to handle transient data at a page level. So this is the other type of state dictionary that's available. So each page comes with its own state dictionary, again, which is a key value pair where you can persist any transient data that you want to survive this tombstoning behavior. Okay. Now, remembering that these state dictionaries won't handle an application close and relaunch, so it's really just to handle the deactivating and then the activating cycle. So here we can see that we're in the onNavigated_from method, and what we're doing here is saving out the current context of this log text box to the current state dictionary. So this is within an actual page within your application. And for those who aren't familiar with a Windows Phone application, every time your page launches or is navigated to, there is a method called onNavigated_to. This method always gets invoked regardless of how you navigated to that page. Similarly, when you leave a page, there's an onNavigated_from method that always gets invoked. Okay, so when you arrive at a page, you get onNavigated_to. When you leave a page, it's onNavigated_from. Now, it's up to you within your page as to whether you override these methods. These methods will get called regardless of whether you override them or not, so they always exist in that pair. If you choose to override them, like we have here, you can actually, your code will get invoked as part of navigating to and from the page. So in this case, we're saving this entry when the navigation mode is not a back operation. So if the user is navigating off to another page in our application, or we're navigating off to another application in the system. So this information is going to be persisted into the state dictionary, and then at a later stage when we navigate back, the onNavigated_to will get invoked. Okay, and essentially, because it's a state dictionary, we do need to check to see whether the key exists, and then we can repopulate the text box. Okay, just reiterating, the onNavigated_to and onNavigated_from occur as a pair. There's a great opportunity for you to actually persist information to the state dictionary. Now, again, you don't need to wait until the onNavigated_from to populate that state dictionary. In fact, as the user goes through and populates a form, particularly if it's a long form, you don't want to wait until the onNavigated_from, because it might take a little bit of a time to actually populate that state dictionary. You don't want to hold up the user when they're navigating between pages. So it may be that as the user goes between fields on your form, you actually persist things into the state dictionary. The other thing you'll notice is that there's a new dashboard in Visual Studio 2012 that is specifically for Windows Phone. It's called the Simulation Dashboard. And essentially this allows us to simulate a number of different things within the application. So the key ones for around the activation and deactivated events is the use of the lock screen. Okay, so you'll see here that midway down the simulation dashboard, you can actually trigger the emulator to lock or unlock. Okay, so I'll just flip over and I'll show you the emulator, and we've got Visual Studio. I'm just going to create a new project quickly. So new Windows Phone application, we'll go with that. It's a Windows Phone 8 project. And from the Tools menu, once our project's been created, the Tools menu, Simulation Dashboard, and what we'll see here is if I click the lock, you'll see that the lock screen comes up, and when I click Unlock, you see the lock screen goes away. Okay, so that's a great way to actually test how your application behaves when it's activated and deactivated. One thing I would like to just step back and actually recover for those who aren't familiar with is just talk about the navigation model within Windows Phone. As with a number of other platforms, an application is made up of a number of views or pages. In this case, we often refer to as pages, and essentially the user is going to navigate between those pages. So in this case, Windows Phone refers to this as a navigation method. So we navigate from one page to another. Okay? And in doing so, essentially we build up this back stack within our application of pages. So as we navigate from page 1 to 2 to 3, we get a back stack of page 1, 2, and 3. So we can then press the back button, go back from 3, back to page 2, back to page 1, and then we close our application. And just remembering that there's a second dimension to the back stack, which is of course between applications. So as the user goes from application 1 to 2 to 3, again, the back button will allow them to go back between those applications. Okay, so you remember that the system remembers the backstack for all of the applications and for all of the, within the applications, the pages within those. And actually, this backstack actually gets retained by the system even when your application is tombstoned. So when your application comes back into the foreground, if the user was on page 3, it'll take the user directly to page 3. Now the important thing to remember here is that the application, or the system doesn't navigate the user to page 1, to page 2, and then to page 3. It goes directly to page 3. So if you've actually coded your application to rely on page 1 and page 2 loading data into memory, then when the user comes back into your application after tombstoning and goes directly to page 3, all of a sudden your application is going to fall over because it's expecting data there that's not. So you need to be very careful in actually structuring your pages so they can be self-sufficient. Now, for performance reasons, you can rely on data that's coming from that's loaded by page 1 or page 2. However, you do need to have a process whereby if that data doesn't exist, then you go looking for it on disk. So you basically might load or look to see if a file exists and then load that data into memory. Or you might go off to a service and actually pull that data down. Okay? But you do need to have a strategy there that actually works out how to load the content of the page, and don't just rely on that data being there from the previous pages. Now, the one other thing to be aware of, in particular in Windows Phone 8, is that applications can now start from a number of different locations, essentially. So when Windows Phone first came out, there was really only one way an application could be launched, which was from the start screen. Okay, so all the application list. Doing that would essentially launch the application and always launch it on the main page of the application. Now, there's a number of different mechanisms that we can have for actually entering the application at different points. So, for example, you can now pin different parts of the applications, and each one of those pinned tiles will actually take the user to a different location within the application. So it might navigate them directly to page 2. You can have reminders, you can have file associations, you can tap into Bing search, you can use the wallet, you can use speech. Each one of these different methods can actually launch a different part of the application. So file associations might go directly into a page called File Handler page, or a reminder might go to a reminder page, etc., etc. Okay. One thing you do need to be aware of course, that if the user navigates directly into a page within your application, they might expect some different behavior. Okay? If they come from the start screen, so for example, I clicked on a secondary tile, chances are when they press the back button, they're expected to go back to the start screen. However, in other cases, the user may be so familiar with the application that if they're on a deep link page, they might be expecting when they press the back button to go back to the main part of the applications. So this you really need to treat on a case-by-case basis and work out how your application should best behave. Okay. One example is the Qantas application. In there, you've got the ability to pin a flight to the start screen. When the user clicks on a pinned flight, it takes them into the application and goes directly to the flight details page. Okay. Now, rather than trying to interleave a page when they hit the back button and take them back to the main list of flights, we're actually preserving the user experience there so that they can actually go back to the start screen. However, we do include a home link as part of the menu or the application bar so that they can get back to the main part of the application. Okay. The other thing that was added as part of the Mango update, so Windows Phone 7.5, is the ability to actually manipulate the backstack. So we can actually query to say, okay, is there anything on the backstack? So in this case, navigation service.can go back. It's basically a detection to see whether there is any items on the backstack. And we can actually remove entries off the backstack. Now there's a note on this slide that we can't actually push entries onto the backstack. However, what we can do is we can capture the event when the user navigates back. So for example, if they're on the main page of our application and they hit the back button, if we want, we can actually redirect them to an alternate page within the application and thereby introducing an entry onto the backstack. That kind of thing is not really highly recommended, but there are certain circumstances where that makes sense. You've got to bear in mind that the thing we're after is a very consistent user experience and particularly a consistent use of that back button. So if the user hits the back button, they're expecting to go back to the previous page within the application or back to the previous application they had open. You can also, there's also an event handler that does get invoked when a page is removed from the backstack. So again, you can actually intercept that and handle that appropriately. So just a note here, again, it's all about consistency for the user experiences. So you need to make sure that however you handle the backstack, you do it to make sure that it's a consistent and a nice user experience. Okay, I touched on fast application resume early on. Essentially, this is a mechanism whereby the Windows Phone can actually reuse the currently running instance of your application. So prior to Windows Phone 8, if your application was running and the user navigated away from your application gets suspended, still in memory. Now the user goes back to the start screen and they might hit on a secondary live tile for your application. So this would normally take them to, say, page 2 of your application. What it's going to do is it is actually going to tear down the current instance of your application that's in memory. It's going to relaunch your application and go directly to page 2. With Fast Application Resume, we can actually bypass that process of tearing your application down and relaunching it, and thereby making it much quicker to launch your application again. Okay. The thing to watch here is that when your application gets resumed as part of this Fast Application Resume, it's going to come back to whatever page the user was last on, and then navigate off to the page that it needs to be launched. So, for example, the user might have gone page 1, page 2, page 3 in your application. They might have gone away from your application and clicked on a secondary tile. This secondary tile would normally take them to page 2 of your application. So using Fast Application Resume, your application comes into the foreground on page 3. So we've got a backstack of page 1, 2, and 3. And now it's going to navigate to page 2 in your application. So now we've got a backstack of page 1, page 2, page 3, and back to page 2. And so this is going to be really, really weird for the user when they now press the back button and they go, okay, well, I was expected to go back to the start screen, but now I'm going to go back through these pages within this application. So we'll talk about in a second how we handle that, but essentially what we need to do is actually remove those pages from the backstack. Okay, so when your application does get Fast Application Resumed, you need to detect it and actually remove the existing pages off the backstack and then navigate to the new page. So to enable Fast Application Resume, you actually need to add a couple of entries to the app manifest file. Now there's no user interface for this, so you do need to manually edit the code file. And essentially you're adding two things. You're modifying you're just modifying the default task to include this background execution for location tracking. Now this might be seen quite bizarre in the context of just introducing Fast Application Resume. Essentially what they're doing here is they're using the same modification to the manifest file to introduce two different types of Fast Application Resume. One is the Fast Application Resume we just spoke about, where your application just needs to come back into the foreground quicker. The second type is actually to handle the ability to track location in the background. Okay. One of the challenges with the previous iterations of Windows Phone was if you wanted to build the run tracker style application. So this is the style of application that stays running in the background, tracking the user's location, for example, when they go for a run. The only way to do this was actually to have your application run in or disable the idle detection mode on the device. And essentially what this would do is it would allow the lock screen to come down over the top of your application. Your application would still essentially be the foreground application of the application that's currently running, but it would be allowed to run under the lock screen. This is okay, but it's not great because if the user then gets a call or they need to change the music they're playing or do anything else on the device, they're going to navigate away from your application, which all of a sudden stops your application from tracking location. So one of the flavors of Fast Application Resume is the ability for your application to essentially stay running in the background and track location. So essentially what happens now is your application, when the user navigates away from it, if you are tracking location, and by this I mean that you've got an instance of either the geo-coordinate watcher or the geolocator class, and you've attached the event handler for when the position changes, your application will actually get another event instead of the deactivated event that basically says you are now running in the background. Okay. Now clearly if the user comes back to your application will come to the foreground essentially out of that background operation. Okay. So the location tracking is one flavor, and then the ability to have your application comes back into the foreground is the other flavor of fast application resume. So the challenge is, okay, well, why don't I use this in all my applications? Well, essentially the reason is that, as I described before, is if you don't handle this fast application resume properly, then the user's going to get this really inconsistent experience. So the idea that they go page 1, page 2, page 3, and now they've got page 2, and so they've got this backstack that goes through all of these other pages of the application that they're not expecting to be there. Okay, so this is just highlighting the flavor of fast application resume, which I spoke about. Yeah. So if you're using the location tracking that's running in the background event, gets raised instead of the deactivated event, and that's your opportunity to start tracking location or continue tracking location in the background. Okay. The point here is that when your application does get resumed from using fast application resumed, the current page on the backstack gets navigated to with a mode set to reset, and then the new page that they're navigating to actually gets invoked with the standard navigation mode of new. Okay. Now, within a new Windows Phone application, so the project template that comes with Visual Studio, there's actually some code in here which actually will handle removing unwanted pages from the backstack. So in the scenario we had before, when the user gets sent to page 2, rather than having page 1, 2, and 3 in the backstack, this boilerplate code will actually remove those. Okay, so essentially what we're doing here is part of the initialized phone application. You'll see that we're wiring up an event handler to the navigated event on the root frame. So essentially this is going to get invoked every time we do a navigation within the application. And within the code, we're actually detecting to see whether the navigation mode is set to reset. If it is, and remembering that this is for the current page on the backstack, what we're doing is we're actually wiring another event handler to the navigated method that says clear backstack after reset. So essentially what's going to happen, remembering, is that we're coming in to the existing page. So in our scenario, it was page 3. We're now going to navigate off to page 2 again. And so when we get to page 2, we're going to essentially go through and remove everything off the backstack. And that's what this clear backstack after reset method actually does. So you can see here that it removes the event handler and then goes through and actually removes all of the existing entries on the backstack. And essentially this is code that you can actually take from the default project templates and actually add to your application. So for example, if you have a Phone 7 application and you've upgraded to Windows Phone 8, so you won't have this code, you can actually take this code out of the template project and actually introduce it into your application so that you can then enable fast application resume within your application. Okay, so that in a nutshell is the life cycle of a Windows Phone application. We'll move along straight away into the background agents. I would encourage you to spend quite a bit of time just getting familiar with the life cycle approach of Windows Phone. It is a little bit different from some of the other platforms out there, and it is important that you do understand the differences between Dormant, Tombstone, and what happens as part of launching your application. So there's a number of different types of background agents that we'll cover. And essentially, because Windows Phone only allows a single application to run in the background, when your application is not running, we need mechanisms to handle certain things like, for example, updating data, or for tracking information, or even in the case of the audio task, the ability to play audio in the background. The trade-off and one of the reasons why, and the primary reasons why we only have one foreground application, is to make sure that the user experience is the best possible for the currently running application. Okay. The other reason is to make sure that the battery life of the device is optimal for the user. So we don't want 3 or 4 applications all running at the same time. So with Windows Phone 8, we now have the ability to do location tracking, which is essentially a continually running application in the background. And that's the only exception to this rule. Okay, every other application there is only ever one application continuously running in the foreground. The rest of them have the opportunity to run tasks in the form of these background agents. Okay, and essentially a background agent is essentially almost like another application. In fact, when you build a background agent, you build another assembly, and that assembly gets or DLL gets invoked completely separately to your main application. So in fact, they can actually run at the same time, and in fact, it's one of the scenarios you may need to deal with in your application. And we've got a number of different types of these background agents. So there's an example of a periodic task, okay, and a resource-intensive task. One thing to note is that these tasks or these agents aren't the same as a foreground application. There are some limitations about what they can or can't do, and there's also no guarantee that they will run. So for example, the periodic agent is designed to run every half an hour. Okay, but the user has the ability to constrict this and actually modify the conditions for when these tasks or agents will actually run. Okay, so for example, you want to make sure that in this case, this number of points here, these are giving you some scenarios under the conditions where the agents may not run. So for example, if the phone goes into power save mode, it will stop running those background agents completely. Okay. It's up to the user. They can actually go in and modify which background agents can actually run and can actually disable them for certain applications. Okay, and again, so it's really all about the user having the control to actually control the performance and the operation of applications on their device. So one thing to bear in mind when you're structuring your background agent is because they may not run, you need to make sure that your applications are not inhibited in any way. And that background agents are really a value add that you can build on for your application. So essentially there's two types of tasks that you can invoke that run periodically on the device. Okay, so there's a periodic task, okay, and the slide here says it runs every now and again. Essentially it's designed to run approximately every half an hour, give or take. Okay. Now a resource intensive task is designed to work under certain conditions. So it's normally when the user's got their device plugged in and when it's on Wi-Fi, and they've got the ability to actually do some longer running tasks. Okay. So as I said, periodic tasks are designed to run every 30 minutes or so, and there are some additional constraints that are placed on those agents. So it can actually only run for a certain amount of time, so approximately 25 seconds. It's got to use less than 6 megs of memory, and particularly if you're dynamically creating live tiles, you may want to think about this because it can actually affect the amount of memory that you're using. So you need to make sure that you handle that appropriately. And you've got to be aware that under certain conditions, your background agent may stop running. So for example, if it crashes twice, it'll actually, the schedule will actually stop invoking it. Okay, and the user will have to go back into your main application in order for it to be rescheduled. Now, in certain cases, this is a quite good agent for doing things like location tracking, so long as you don't need turn-by-turn location tracking. So it's good for getting a rough position of where employees are over certain intervals, or even looking up to find out where your device is. Okay. It's also good for sort of those long-running background services. So, for example, looking to see if data's changed on the server. And for doing updates to the local, the tiles that the user might have pinned to for your application. The other types of agent is a resource-intensive agent. Okay, so this gets a few more cycles to run, so it can actually run for up to 10 minutes, and it's generally triggered when the phone has got a high percentage of charge, it's powered by the mains, and is connected to a Wi-Fi area network. Okay, again. If the application's crashed a couple of times or the agent's crashed a couple of times, the schedule will stop scheduling it, even if the user has put their device onto charge and is on the Wi-Fi network. I mentioned there's a couple of other restrictions on these background tasks, and remembering that they are running in the background. So doing things like manipulating the UI, they can't do. There's certain XNA libraries that they can't access. So for example, your background agent can't start spinning up the microphone and recording conversations and things like that. It can't trigger look at sensors, and with certain exceptions, it can't play audio. That said, there are a lot of things that the background agents can do. So, for example, it can update tiles. Okay, the caveat there is that they can't create tiles because that will actually drive the user to the start screen, which would be a very unpredictable behavior. However, the background agents can update tiles. They can actually trigger local toasts, so you can actually notify a user. In fact, there's the Sydney Morning Herald application just got released for Windows Phone, and the toast notifications periodically come up for that application. And quite a few of them, I would imagine, would be driven by a local background agent that periodically goes off and looks at new news articles and actually triggers that toast notification. You can detect location. You've got network access, and you've got the ability to read and write to the local file system. So you've got quite a lot of capabilities to what you can do. Just be aware that you do have the time and the memory constraints on what you can do with those background agents. Creating a background agent is relatively straightforward. There are a number of templates that come with Visual Studio. So you can see here that this is a scheduled task agent. Okay, so that's going to create essentially a periodic or a resource-intensive agent. Within your application, your main application then needs to have a reference to that. So you can see here that the Visual Studio solution, we've got the main application, so location logger, has actually got a reference to location log task agent. Okay, so that's the agent. In actual fact, Visual Studio is quite clever. So when you actually make that reference, it'll actually add a line into the app manifest file to make sure that the two are correctly bound for initiating the background agent. In the background agent itself, essentially there's one method that you need to provide code for, and that's the onInvoke method. Okay, so this is the method that gets invoked for a periodic agent every half an hour, and for a resource-intensive agent when the conditions are appropriate. So essentially, you've got to perform your code, and then when you're done, you need to call the notify complete method. Now, it's important that you don't execute other code after you've called that notify completed event, because essentially, once you've called that method, the system starts to shut down your background task. Okay. So one thing you probably need to do here is you'll need to make sure that if you hand off to another thread or do some background type style operation, you need to make sure that you don't call that notify method until that other thread is completed. Now, obviously, with the support for async and await, again, you can call those methods and just have a single thread of or a single line set of code to walk through. You just need to be aware of the time constraint on these tasks and making sure that you've got the ability to cancel those long-running tasks if you need to. So, for example, here we're actually showing in the onInvoke method, we're actually showing a local toast notification. So, using the shell toast API, creating a new toast, and then we're invoking the show method. And you can see that that's going to appear across the top of the device. The user clicks on there, and it'll actually launch your foreground application again. Now, in addition to actually having a reference to the background agent from your main application, you also need to actually schedule the background agent. Okay, so here we're actually triggering the background agent as a periodic task. Okay, so you can see here we're going to look for any existing tasks. If one's not found, we're going to create a new task, set the description, set the expiry date. Now, it's important to rerun this code every time your application is launched to make sure that it's going to stay running in memory. Okay, so it stay executing. If the user hasn't launched your application in a 2-week period, any background agents associated with your application will not get executed again. So it's important to try and encourage the user back into your application at least every 2 weeks to make sure those background agents will continue to run. Okay. If we haven't found the periodic task, we're going to actually add that to the scheduler. Otherwise, we're going to remove and add it. And this is, again, that process of making sure that it won't expire, essentially. So it'll actually, when the user leaves your application, you'll get another 2 weeks before your background task will get removed from the scheduler. Now, debugging a background task, rather than having to wait for it to trigger, i.e. every 30 minutes for a periodic or under the right conditions for a resource intensive, we can actually call the launch for test API. Now, this will only work in debug, and it's a really convenient way for actually invoking your background task. Okay. In most cases, I actually drop the time span from 60 seconds down to 1 second, just so it triggers almost straight away. So a couple of tips, just make sure that you renew often so that the process of removing any existing task and adding it back in again. Don't make it mission critical that your background agent runs, because the user can disable them, and then under certain circumstances the background agent can be disabled as well. Okay. Now there's a couple of other things that you can do in the background, and one of which is the ability to transfer files. So for example, the thing about mobile applications is that users tend to go in and out of applications quite quickly. And if you need to do like a synchronization of some data, or you need to download some files on the user's behalf, it's quite probable that the user will want to leave your application. So rather than trying to do the download within your application, getting halfway through and then the user leaving your application, which will effectively terminate the download, you can actually schedule or trigger one of these background file transfers. Okay, you can actually use this to download and upload. Okay, there's a couple of caveats. Okay, at the moment FTP is not supported, and once you trigger the downloads, you can actually then requery the status for those downloads. Okay. In addition, maximum upload size 5 megabytes, maximum download size over a phone network is 20 megs, and then over Wi-Fi is 100 megs. Okay. One of the nice things for Windows Phone is that the number of background transfer requests that you can trigger per app at any one time has gone up from 5 to 25. Okay. And just bear in mind that those will not, when the user leaves your application, those won't necessarily happen straight away. They'll actually happen when the device is not being used or when there's good network available. So to trigger a background transfer, we need a reference to the background transfer namespace. And unlike other background agents where you'd have to create an additional project to handle the background agents, you can actually do this from your foreground application. Here we're going to establish a new background transfer request, okay, providing the URI that we're going to retrieve the data from, and we're going to do a get here. If you're going to be uploading data, you can actually use the post method. Then from there, what you're going to we've got to specify the location on the device where it's going to be downloaded to, and you do need to make sure that this is in the shared transfers folder. Okay, so it's one of the special folders that we talked about last week that allows where the user can actually download content to. Once we've actually created an instance, then we actually literally add that instance to the background transfer service, and that'll actually trigger the start of that transfer. Okay, you can then requery them and actually retrieve events as to how the progress of those transfers goes. So, for example, if you have more than 25 transfers to do, you can trigger the first 25, and then you need to keep a queue of the remaining files. So when one completes, you then schedule the next one, and the next one, and the next one. The one challenge there is, of course, if the user leaves your application, you then need to detect how far through that list you've got, persist that to storage, and then when your application launches again, you can actually requery the transfers and go through them. And they aren't removed out of the transfers list until you actively remove them. So even if they complete in the background, they'll still be there, so you can query their status. So there's a good example on MSDN for how to handle the background transfers. The other type of background agent that we can do is actually an audio agent, and there's essentially two types of audio agents. There's just a regular background audio, which is essentially playing media files, and then there's actually a streaming agent that we can create as well. So again, there's templates for these within Visual Studio that you can actually get started with, and they work very similar to the periodic and resource-intensive tasks that we saw previously. Once you schedule them, they actually trigger off and actually will kick off. Okay. So just going to move now on to the use of tiles and push notification for Windows Phone. Obviously, one of the most iconic features of the Windows Phone platform is this concept of live tiles. Okay, so in Windows Phone 8, we have now got additional tile types, and we'll cover off how you can use push notifications and local notifications to update those tiles. So back from the original Windows Phone, we really were restricted to only having a single tile for our applications. So essentially, your application, the user could pin your application to the start screen. With Windows Phone 7.1, we now have the ability to have multiple live tiles for a particular application, so it can pin different parts of the application. So, for example, in the Qantas application, they could pin a particular flight to the start screen. And we have local APIs so that we can actually update them. Alternatively, we could use push notification, or we can actually schedule updates to actually update them on the fly as well. So a bit of an overview of live tiles. Okay, so one of the functions is a shortcut to the app. Okay, so that was the original idea or the original implementation of a live tile. However, now as we move into Windows Phone 8, we've now got a much richer set of capabilities around live tiles. We can create additional live tiles or secondary live tiles for our application, and those can launch any page within our application. Those live tiles can now be static, so we'll just set them once and leave them, or we can dynamically update them. So those tiles can be updated from our code that runs, so we've got a local tile API that we can call to update them. We can update them from background agents. And essentially this also uses the local tile API, but it's actually from the code that runs in the background. And we've got the ability to schedule push notifications down to your server platform, down to the device in order to update those live tiles. For Windows Phone 7.1, we only had one tile size for third-party apps. So essentially, if you were one of the special few apps, so for example, the calendar apps, a first-party application, you actually got this wide tile format. But third-party apps were constrained down to this big square 173 by 173 tile. With Windows Phone 8, we've actually got three different size tiles that we can target. We've got a small, medium, and we've got a wide tile. And in fact, all applications out of the box will support the small and medium live tiles, and it's optional for the application to support. And in fact, you can define this on a tile-by-tile basis as to whether those tiles actually support the wide format. The other thing that was added in Windows Phone 8 is an additional tile set of templates. Okay, in the original Windows Phone only had a single template for the live tiles, so basically you're updating the front of the tile, which had a background, it had a title and a count property. With 7.1, we now have the ability to target the back of the tile. Okay, so we had this kind of concept of a flip tile. With Windows Phone 8, we now have three different templates that you can target. So this is building on some of the work in the Windows 8 space, where there's multiple different templates that you can use for your live tiles. The flip template pretty much remains the same, with the exception that you now have this wide tile format that you can interact with. The iconic template, as you can see in the middle here, it's basically to cater for those applications that don't necessarily want to put imagery on there, but they do want to highlight the count or the number of unread items or the number of points of interest for the user. In the past, this was conveyed by this little black dot that appeared with a count appearing in it. And in 99% of the cases, this was really, really ugly and didn't look at all good, so most developers steered away from it. What developers did ask for is the ability to render this count in the same way as the system applications do. So for example, the email icon, when you get an unread email, the email would actually shift across slightly and the number of unread emails would appear alongside it. So the iconic template is essentially there to provide that to developers. And lastly, we've got a cyclic template that allows up to 9 images to iterate through. So these basically dynamically change in front of the user's eyes. So, and there's a really nice sort of effect that gets that's part of that. The content for the tiles has actually changed slightly. Okay, rather than a tile size of 173 by 173, which is the default template for 7.1, we now have a standard tile size of 336 by 336. Okay, this is really to handle those high definition displays, and obviously it's scaled down on the low resolution devices. We've also got small and wide tile format that we're going to have to cater for. The only exception to this is the iconic templates. Okay, this actually uses icons that are or images that are slightly different size, depending on whether you've got the small or the large tile pinned. And then, in fact, in the wide tile format, it uses either the small or the medium tiles, the image size, depending on whether you've actually set the content for the wide format. So, for example, if you come back here, you can see that in this case, the iconic template has actually got content set, so the text at the top there, in which case the icon that's been used here will be the small one. If this text hadn't been set, so there's no content there, it would actually use the medium size image there. Just going through the tiles in a little bit more detail. So this is the flip tile template. You can see there's a number of different properties that we can now set on that. Okay, some of these have come across from the original Windows Phone tile template. So you can see title, back content, back title, background image, background image. But then there's some new ones like wide background image and wide background image and small background image. Okay, so these are the additional things that you can set as part of creating your tiles. The cyclic template, as I mentioned before, it's up to 9 images, and then again you specify as the properties for the tile. The iconic tile template, Same deal. You've got the count, you've got the title, but now you've got the iconic image and the small iconic image, and you've got these properties wide content 3, 2, and 1 that get set as part of the wide tile format to display more information about your application. So just to recap on the difference between a primary and a secondary tile. So if you hear people talk about the primary tile for an application, that's the tile that gets generated when you pin your application from the application list to the start screen. This tile always exists regardless of whether the user has it pinned or not. And one thing to note about the primary tile is once you can take advantage of the different the different tile templates, one of the limitations on the update process for tiles is that you can't change the template that you're using. Now for secondary tiles, this isn't too much of an issue because we can essentially delete the secondary tile and then recreate it with a different tile template. However, for the primary template, the primary tile, you can't change the template that your application gets deployed with. Okay, so it's important to make sure you get that correct as part of your application. Defining the application tile. Okay, you'll notice that as part of the new Windows Phone 8 project templates, you'll see that there's a bunch of images that are provided as sort of templates to get you started. And then you can actually set these as part of the manifest editor. Okay, so if you actually double click on the app manifest file, you'll see this editor come up where you can actually specify what tile template you're going to use and whether you're going to support large tile size or not. So that's the widescreen, the wide tile format. Remembering your application has to support, all tiles have to support the small and the regular size tile. And basically the checkbox here, and in fact there's a property when you go and create new tiles to actually say whether you support the wide tile format. Okay. In this case, we are going to support it, and we've specified the images for the small, medium, and large size tiles. So using the local API to actually create tiles, okay, noting that these are not using push notifications, they're essentially all done when your application is running in the foreground or in the background. Okay, you can use it to essentially manage those secondary tiles, so you can use it to create, update, and delete, and those second tiles basically will launch different parts of your application. So here we've got 3 tiles. The application tile is going to always launch our application, and then secondary tiles that launch different parts of our application. So here's a bit of code that does just that. So we're going to essentially create, in this case we're creating a flip tile data, okay, and we're setting a number of different properties. Now one thing you'll note here is that if you come from Windows Phone 7, the format for these the URLs here are slightly different. Okay, so here we're actually using the ms-appx prefix on it to indicate the location of the images. Once you've actually created the tile data, we're then going to use the create method on the shell tile to actually, and passing it in the URL that we're going to launch from this tile. And the last parameter on here is the new parameter. Okay, so this indicates whether we're going to support the wide tile format or not. Updating tiles, it's literally a matter of locating the right tile. Okay, so here we're basically iterating through the active tiles to find the one that contains default tile equals from tile as part of the URI. And once we've found that, we can then specify the new data that we want to apply to that tile. So again, we can update the application tile, remembering that we can't change the template that we're going to use for our application. Okay, so literally we're just updating the content for that tile. So to specify the application tile, so this is the primary tile for our application. We basically pull off the first tile that's in this active tiles list. Okay, so this is true whether it's been pinned or not. Another method for updating the tiles is using a tile schedule. And essentially this is a queue or a schedule for the operating system to go away and update the tiles on a recurrence frequency. So you can set it to be on an hour, every day, every week, every month. Okay. So doing this looks a little bit like this. So essentially we're creating a new instance of the shell tile schedule. We're setting the recurrence, the interval, the URI where we're going to be downloading the image from. And remember, we're just using this to update the image on the front side of the tile, and then we're triggering start. Okay, so in this case, it's going to trigger off every hour and go ahead and update. And because we're not specifying the max update count, essentially this schedule is going to run indefinitely. Now, we can also specify a shell tile schedule for secondary tiles. Okay, the only difference here is that we're passing in the tile as a parameter into the constructor for the schedule. From a background agent, essentially in order to update a tile, we're just going to use the local tile API. Prior to 7.1, we actually had to use push notifications to do this. Okay, so we needed something running on a server that actually pushed those changes down to the device. Now we can actually use the shell tile API, so it's a local API to actually update those. One of the nice new features of Windows Phone is the ability to actually modify the lock screen. Okay, so this is another entry point, or another point where your application gets to integrate with the platform. Okay, so now we've got the ability to specify the background image, so we can be the background image provider for the lock screen. Your application can specify the notification text that appears and an icon that appears in this bottom tray area. So the user can actually define these. And so these are the three different areas that we get to modify from within our application. So there's a new settings area. In the settings area, the user can actually specify where the background comes from and which applications are controlling what appears in the notification area. And finally, which applications appear. So the user can specify 5 of them. What applications appear in the quick status area. So to actually create a lock screen icon, it's really easy. So this is the icon that appears at the bottom of the screen. So here you can see there's a little unicorn down here, there's a little icon down here. So these are the lock screen icons that we're referring to. Creating those is really easy. It's 24 by 24 pixel, and essentially should only be white pixels with a transparent background, because remembering it's going to sit over the top of that background image. And so essentially to do this, we're just going to specify, we're going to modify the manifest file to actually include the name of your lock screen icon. We also need to modify the manifest file to indicate whether we're going to provide, in this case we're going to set it to be the icon provider and also the provider for the notification text. So this goes into our manifest file as well. To update the count and the text, literally this is linked to properties actually on your primary tile. So the count is linked to the count property on the primary tile, and the text is actually linked to the back content property on the tile. Again, these can be updated just by updating the primary tile via the local shell API and via push notifications. So to trigger the lock screen so you can actually see it, again, use the simulation dashboard to actually pull down the lock screen and actually take a look. So let's actually flip across to Visual Studio. We're actually just going to do this really quickly and go to Solution Explorer. We're going to open up our manifest file with a text editor because there's no UI for this. And you'll see here that what we're going to do is we're going to specify a lock screen icon. So it's going to be my icon.png. We're going to specify a count of 5 and a back content of my custom lock screen content. Okay, and we also need to update the extensions in here. So remembering that this needs to actually go immediately following the tokens attribute here. Okay, so that's all we need to specify in the manifest file. Okay, so and the reason I'm specifying the count and the back content here is just so that I don't have to dynamically update them. Clearly, if you're pushing out your application, you probably wouldn't set these initially. You just update them using the local API. I'm actually going to open up an image editor, and I'm going to do it with the application icon. Okay, so double click on that. So this is our normal application icon. It's 100 by 100. You can see here. I'm actually going to resize this. It's down to 24 by 24, and save this back down into here. Within our application, so apply. And I've just got to include this in my application now. So show all files, include this in my application. And it's, as is the way with demos, this is when Visual Studio decides to restart itself. Bear with me for 2 seconds. We reopen that application. Okay, so we did actually save the manifest file, so we don't have to remodify that again. It's going to show all files and attempt to include this file again. Put it in there. So we'll just double check that the contents, that the properties on here is actually set to content. So we can do that by looking at there. Okay, I've launched my application. Okay, so that's the application. And so essentially by deploying and launching our application, now the user can actually go to the settings screen on the device. And you'll notice here that we're working with essentially a full device. We go to settings, go to lock screen. You can see that our application is now listed here. So Phone Application 24 is the application we've just deployed. And we'll specify it as the lock screen, the icon as well. And we'll actually go ahead and, okay, so let's just pull that to the front. And we'll just go back to Visual Studio, go to the simulation dashboard, trigger the lock screen. And what we'll see when we go back there is we have got the custom content there, so in the back content property. We've got the count, but we don't have our icon. And that's because I've forgotten to add a couple of properties into the manifest file. So you'll see here with the other images that we've referenced, these have all got these properties set, or these attributes set. So I've just got to make sure I set those for the lock screen icon there. So I'll actually rebuild my application. Essentially what this is going to do when I actually run it again is it'll actually redeploy our application out to the device. Okay. As with the real device, you can't deploy whilst it's locked, so I'll unlock it. I'll rerun it again. We'll go back to our application. We'll close the application. We'll trigger our lock screen. Okay. So clearly as part of redeploying it, it hasn't actually remembered that I've got to set it as the settings because it's removed the application from the device. So go back in here, set the application, and we'll trigger our lock screen again. And there we are, have our icon and our content property. Okay. Okay, so essentially that's our lock screen. We can actually also update the background. So again, in that same settings area, the user can just define the back screen provider. Within our application, again, it's another setting that we need to provide as part of the manifest file. And then we also need to write some code to actually detect whether we're actually the lock screen provider. Okay, so this code essentially requests access to the lock screen. So it basically says or a request from the user to make my application the lock screen provider. And then we're querying to say, if it is the lock screen provider, then set the image for the lock screen. Okay, so relatively straightforward code. The user is going to see this type of interaction, so they're going to be prompted to see whether to set the current application as the lock screen provider that's triggered off by this request access async. Just a note here that in order to access local images, if it's packaged with your application, then it's ms-appx. If it's in isolated storage, then you need to make sure it's in the local shared shell content folder. So actually, within isolated storage, it's shared /shell content / the image name. But when you're referencing it, it's ms-appdata and /local/shared. Okay, push notifications. So this is the final section. This is the ability for us to push down updates down to our live tiles or to trigger a toast notification from a server. So when something interesting happens on the server, we can actually push this information down to the device. Okay, so we'll go through this quickly. There's a number of scenarios where this is useful, and primarily it's for driving things where things have changed on a server. So it may be the server is monitoring the progress of the task, and it wants to communicate an up, down. Okay. It does enable a number of background scenarios, and where it's particularly good for preserving battery life and the user experience on the device. Okay, so rather than enabling multiple applications to run in the background to do work, that work should be pushed up to a server, carried out, and then a notification pushed down to the device. Okay, essentially it also reduces the need for your application to continually poll off to a server because it can actually get those updates back from the server. There's three types of notifications that most people will be familiar with. There are raw notifications that come directly into the application. If it's running, if the application is not running, they get ignored. There are toast notifications that come in that are similar to an incoming SMS. And then finally, there are tile notifications that are similar, that don't come into the application at all, that are really used to dynamically update the content on the tiles. Now, there is additional types of notifications for applications that are providing VoIP services. And there is essentially enabling an application, a VoIP-style application, to be launched when it's not running in the background. So, the application is closed. So take Skype, for example. This works in the same way as you can go build your application today. Essentially, when Skype's not running, the user's actually closed, they still want to receive a call. Okay, so this is done by a type of notification to trigger off that VoIP call. The process to use push notifications from your application, the first thing it needs to do is actually establish a channel with the Microsoft hosted services. And as part of that, you get back a channel URI. This channel URI needs to then be commuted off to a third-party service so that that third-party service can send a notification to the device. When that third party wants to send a notification, it does a HTTP post to that to the notification service from Microsoft, and Microsoft handles pushing that message down to the device. So some of the features, tile updates. Okay, you're limited to 30 applications subscribing for push notifications per phone. There are some limitations on the payloads. Unauthenticated web services, so this is the third-party services that are communicating, are limited to 50 push notifications per subscription per day, so essentially per device, per app per device. And the authenticated web services do this over a secure channel, but and don't have that same limitation on them. So just going through the individual types in a little bit more detail, a toast notification's essentially got two visual components. So it's got a text 1 and text 2 that essentially appear as bold and unbolded text, as well as a params value which determines which page in the application gets launched. So it looks at the content or the message that goes to the Microsoft notification service looks like a bit like this. So essentially you do a HTTP post structured like this and send it to the server to trigger off those toast notifications. A tile update, same process. So essentially the update looks like this for a flip tile template. So again, it just looks very similar to how you structure the tile if you're creating it locally or updating it locally. It's just specified as XML that you're going to send down through the notification services. Here's the cyclic template. So again, just specifying the various different images. And the iconic template looks very similar. Raw notifications, it's really up to you as to what the format for the method is. Here's an example of a random bit of XML that could be sent down as an example, but essentially the content of a raw notification is up to you and the application receiving it to determine the format. There are a number of response headers that the sender will get based on the availability of the device. I actually want to show a very quick demo of getting this stuff up and running, so I'm going to stop this application. I'm going to flip across to the code in the main page, and I've got just a snippet or two of code that we're going to run. Okay. I'll drop this in here, and essentially this looks for a HTTP notification channel. So this is that process of the device looking for or establishing a notification channel. If it doesn't already find one, it actually goes ahead and creates a new one. And what's important is that we wire up this channel URI updated event handler before we call the open method. I'll just grab that chunk of code, it's in here. Okay, and essentially as part of that, when calling the open method, this is essentially, even though it doesn't say it, it's an asynchronous operation, so it basically triggers that open process, or it will establish that, start the establishment of that channel with the notification services. And at some point in the future, that channel will be established and the application will receive back its channel URI. Okay. What we want to do is make sure that we capture that, and in this case, all we're doing is printing it out. So we've just got a debug statement. Now I'm going to actually run this up, okay, in the emulator. And again, I'll endeavor to unlock the emulator before I deploy. I'll actually rerun that again. Aha. So it's triggered an error, okay, and if I look at the data here, it says I need to enable ID cap push notification. So this is one of the capabilities that appear in the manifest file. Okay, now one of the differences you'll notice between Phone 7 and the templates that come in Phone 8 are that in Phone 7, all of the capabilities were enabled by default or checked by default. With Windows Phone 8 templates, they're not all checked by default. Okay, so you do need to add in the ones that you need to use. So this is the push notification capability. We'll add that in and rerun our application. And this time we should see that channel gets established. Okay, so we're expecting that event handler to be hit, or that breakpoint to be hit. There we go. And we can actually see the structure of that, and it's quite a long URL. Okay, so essentially this is the URL somebody needs to do a HTTP post to in order to send a notification to this device. So let me actually close this application now, and we're going to jump across to Fiddler, and I'm just going to drop that URL into here, and I've got the contents of a message that I'm just going to put into here. So we need to set some headers. Okay, this is basically identifying the type of notification we're sending. And in this case, it's a toast notification. So we're going to be sending this toast notification. It's a HTTP post, and if I execute this, what we should see on the emulator is a notification that comes in. Okay, now because I didn't provide the params value when I launched this, it's just going to launch our application again. So here, our event handler has been triggered, remembering that the debugger will actually stay attached as part of that process. Okay, so that's actually the end of the content for today. We did go a little bit longer than I expected, so we've only got sort of 12 or so minutes available for questions in the allotted time, although I will stay around after that to answer any unanswered questions. As next steps, don't forget that the labs are now available on the learning site, so if you haven't already, I'd highly recommend you go to the learning site at this URL and use your email address that you registered for the course and free course as the password. I'd also recommend, if you are based in Australia and you want to stay in contact with the Windows Phone events, news, competition, and more, this is actually run by Dave Glover from Microsoft in Australia. I'd highly recommend going to wp.msdeveloper.com.au, register there, and then you'll get notified of upcoming events, news, etc. If you're in Sydney or you're in Perth, we're actually running a one-day version of this course. It's very similar content. But then the next day is actually a hands-on workshop. So we've got a number of machines set up with Windows Phone 8 and all the tools. So you can actually come in and spend some time working with the toolkit and asking any questions. So there'll be a couple of instructors on hand. So let me just drag the questions over and I will go through them. Okay, so Greg's initial question is whether we can, rather than relaunching the application, whether we can go back to the save state. So Greg, in answer to your question, fast application resumes handles that. So yes, in fact, your comment just after that actually states that you realize that. Okay, so hopefully that handles that scenario for you. Just be aware that you do want to provide a consistent user experience to the user. Now, just because you come from another platform where the expected behavior is to resume the application where they're expecting, doesn't mean you should necessarily do that on Windows Phone. In fact, if you do that, you may find that users object because what they're expecting on Windows Phone is to relaunch the application. So Igor asks how saving, restoring data on activation, deactivation works in MVVM model. Okay, so Igor, it's really up to your application as to how you handle that. One strategy that some people propose is that as part of the deactivation approach, you actually just serialize the whole MVVM model for the page into the state dictionary. I don't particularly subscribe to that. I normally reserve the saving of state information to just what the user has modified on the current screen. So I'll actually reload my MVVM model for the current page and the activation. And then I will look for any information in state dictionaries that the user might have entered. So Igor says that the 2-week expiration period doesn't apply for Windows Phone 8 and is relevant for Windows Phone 7. My understanding was that it's still relevant. I would have to go and double check that. I didn't think that it had changed. That's in relation to the background agents. I will make a note of that and try and come back to you on that one. Can we control what size the tiles are? No, we don't. We don't have control. That's completely up to the user to determine what size the tiles are. The only control you have is to whether you support the wide format or not. So I guess the answer to your question is, well, you can uncheck the box to support the wide format and just stick with the medium or the small one. The reality is that the user, it's up to the user as to how they structure their start screen. That's always been the premise of Windows Phone. Yes, the custom ID GUIDs for the things around the extension area, yes, they are the same. Okay. Can one phone push notifications to another phone? Yes. If you pass that channel URI between phones, you can use it for peer-to-peer notifications. And in fact, you can, in one of the scenarios you might think of enabling there, is the use of raw notifications to do effectively short message passing between phones. I think that number of push notifications has been removed for Windows Phone 8. Again, I wasn't aware that the limitation had been removed. It's unlikely that they've completely removed it. They may have extended it out. Again, I'll have to double check those numbers. All of those samples using local URLs, do remote HTTP URLs work in all of those cases too? Yes, in most cases, remote URLs do work, with the exception, I think, of the lock screen image has to be a local URL. Michael asks, there seems to be a difference in how the back button is handled in Win8. It stops an app page. Sorry, it stops at the app page in Phone 7 or Phone 8. It closes the app. That's correct. Yes, so the behavior is different between Windows 8 and Windows Phone. Windows 8 essentially brings the currently running application into focus. So it's the same model that other platforms prescribe to. Windows Phone is different. Windows Phone, well, by default it's different, so it will relaunch the application rather than just bring it into the foreground. Of course, it's now up to you. You can take advantage of that, or you can essentially just return the user to the existing app. Can I have the PowerPoint, or can you just export the text into Word or text format only if I can't have the PowerPoints? Trevor, yes, the PowerPoint is already uploaded to the learning site already, so you should have already access to the learning site, in which case you can download the PowerPoint slides, and the recordings will be available for all sessions as soon as we can get them uploaded. All right, so I think that gets us through the questions. As I mentioned, I will be here for a little bit longer, so feel free to ask any other questions you might have. Otherwise, feel free to ask them during the week on the forum. I have been checking them relatively frequently and trying to respond to as many questions as I can. So Mark asks, with the icon tiles, can the icons be colored or just monochrome? Actually, Mark, I think you can actually set the background color of the iconic template. So yes, you can. It doesn't need to be monochrome. It can be whatever colors you want. So essentially, it's going to be your image put over some background. So I think if you don't specify the background, you get the accent color. But if you specify the background color, then it will be the color that you defined. So basically, we're always remembering when we close the app, etc. Our variables stay present for quick launching, or they're just dumping full and reloading. So Jonathan, if you don't take advantage of fast application resuming, then yes, when your application, if the user relaunches your application from the start screen, any of those values that were in memory are completely lost. If you do fast application resume, when your application comes in the foreground, because your application was in either the tombstone or the dormant state, your application will be rehydrated, so those state dictionaries will exist, and then you'll be navigated off to the new page. So yes, those data values do persist. Igor's found a great link. Okay, so let me see if I can just double check on that one. I'll watch it so everyone else can see. So Trevor asks, I have an app for Windows 7.1 ported or compiled another version for Windows 8. How do I keep two versions at the same time? Now, just a clarification, are you referring to Windows 8 or are you referring to Windows Phone 8? So my recommendation for compatibility between Windows Phone 7.1 and version 8 is that I would actually continue to build for Windows Phone 7 and just add in additional features for Windows Phone 8 using reflection. So there's a lot of things that you can do just by calling them by reflection. So for example, the save appointment task, you can actually use reflection to create an instance of it, set properties, and actually call it. And obviously, when you're using reflection, if you don't get the type back, if you can't create an instance of it, then obviously you're running on a Windows Phone 7 device. The other strategy is you can use you can share resources. For example, you might have a Phone 7 and a Phone 8 project, and then just share the code files between them. In which case, you can just use hash defines for the Windows Phone 8 specific features. There's a number of different strategies around doing that, and actually, the strategy of sharing code files like that is actually how you probably cater for dealing with Windows 8 as well. So you could essentially have your core code files, so your view model and things like that, would all be shared code that you can share between Phone 7, Phone 8, and Windows 8. And then you can basically have different user experiences for those, or you can add in particular content using hash defines. Okay, let's see what this channel is. So now in Windows Phone 8, as long as the app is pinned or supplying pictures or image to the lock screen, it is no longer the case. Okay, so the 2-week expiry basically goes away. Excellent. That's good news. Thanks for that, Igor. Good link. So Greg, in the labs, there should be a document that walks you through the labs. Let me just double check that they were included. Yep. So as part of the as you go into each of the labs, you'll see that there's actually a document in them, which will actually walk you through the lab instructions. I'll just double check all of them, make sure that they've all got the lab document in them. Yep. Yeah, so they've all got a lab document so that you can go through those. Okay, so Regan asks, sorry, I missed this one. How does the pass application resume, etc., affect the approval process? What would they reject apps on? So Regan, the big thing that they do ping apps for is the correct use of the back button. And essentially, so long as you can justify why you use the back button a certain way, then they're likely to pass your application. My biggest, what I use to check whether I've used it appropriately is, am I taking the user back to the experience that they're expecting, right? So that's my check for rational. Now, obviously, in the policies that they've got set out, they do stipulate how you should use the back button in the cases where you can use it. For fast application resume, if you decide that you're not going to remove the contents of the backstack, I'm not sure actually how they treat that, because you can definitely argue that, well, the backstack is there, the user is expecting those pages to be there, because that's where they were previously. So you could argue that, and I'm sure that they'll probably let you through. My thoughts are that you should probably use the boilerplate code and remove the pages on the backstack, because that's what Windows Phone users will be expecting. Okay? When they go to that start screen and launch their applications, they're not expecting there to be a backstack of data there. All right. Unless there are other questions that people want me to answer, I'll just make a final note is that if things come up during the week that you're not certain of, feel free to just put them down to the forum. Don't be scared of asking questions. And if there are specific things that you actually want me to cover in any of the upcoming sessions, feel free to add those to the forum as well. And we can either discuss them in the context of the forum, or I can actually add them into the presentations that we're going to see in the next couple of weeks. Okay. I really want to make sure that you guys get the most out of this. So if there are things that you want me to cover, then make sure you let me know. All right. Well, thanks very much for attending today. I look forward to seeing some of you on the forums. And otherwise, we will see you next week. Thanks very much, everyone.